Imagine this. You're a big boy. No, wait, scratch that. You're a giant now. You have ultimate suck powers and can suck up anything around you. Pretty absurd, right? Well, yeah, it's fake. Your short ass ain't doing that. But what if something else can do that? Say the Earth, it sucks everything to it, like us. Well, that super suckability is called gravity. So what actually is this magical force? To know that, we'll have to get a bit into history first. Oh, relax, I'll make it short, you goddamn doom scroller. One day, some guy called Isaac Newton saw an apple fall down. And so he looked over at the moon. The moon didn't fall down. He started doubting his powers that made things fall down and tried to find a proper reasoning. He made a random guess that the apple falling down and the moon staying afloat was connected by the same force somehow. Well, the smart bastard got it exactly right. He named the force of attraction. Basically, anything that had mass, which is similar to weight, but not really weight, would suck things up around them. That's right, you're sucking things up right now. But, well, that doesn't make sense, right? You're not Magneto. Well, thing is, you're too small for it to show effect. But that ain't something being 6 feet tall and 200 pounds would fix. Nope, you'd need to be planet-sized. Which is why Earth has that gravity effect, and also why Earth is stuck to its orbit around the Sun. Some 200 years later, another smartass appeared. He was called Albert Einstein, the E=mc² guy. Well, he thought that this force of attraction ain't no force at all. And just to clarify, a force basically means the push or pull of an object. He said that all this gravity thingamajig is actually related to something called space-time. Now, to clarify what space-time actually means, for starters, we know there's space around us. A cube like your room, a pyramid, or a sphere. And as you probably know, these things are three-dimensional with length, width, and height. Well, what if there was a fourth one? That's called time. So what this means is that space and time are directly connected, somehow, forming the lazily put together word, space-time. So what does this even mean? Now for the mind-boggling and chaotic section. Let's say space-time is a piece of cloth. Now there's a metal ball on top of it. It sinks down. That's something with a lot of mass, like Earth. So now space-time is curved down. What the hell does that imply? Let's split this into several sections first. The straight line, very far from Earth. The tilt near Earth. And the curve on Earth. The straight line has the weakest gravity, and the curve has the strongest. We'll cover the effects of space first. On the straight line, there's no convergence of space. You're floating. On the tilt, there's a slight convergence of space. You're slightly attracted to the mass. As for the curve, that's a lot of space together. You're on the ground. Now for the annoying part, time. Same lines as before. Time is straight, so time progresses at a constant speed. The tilt, time is stretched, it progresses slowly. Finally, the curve, time is not straight, but not too stretched, so time progresses faster than the tilt, but slower than the straight line. This complicated concept manages to perfectly prove and predict stuff like black holes, gravitational waves, and time dilation. Now, for the big question. Why and how? Well, it's because, I don't know, I'm not smart, okay? Seriously though, we don't have an answer. However, there are existing theories regarding quantum mechanics and hidden dimensions. But that's a topic for another day. My brain juice is all used up now. Or just wait for the next big brain guy. Might have to take that thought to your grave. I hope you learned something out of all this useless data, because I had one hell of a bad time. If you were looking for a practical answer, you got the wrong place. See ya, chumps.